Good morning, everyone. My name is Dr. Tariq Umar from the University of West of England, Bristol. It is a pleasure to present our paper titled Enhancing High Performance Computing, HPC Adaptation in the Built Environment, a user-centered approach to inclusive digital innovation. This research was undertaken in collaboration with Dr. Sun and Professor James Smith and form part of the UKRI funded project under the National Federation Computing Service Network Plus program. High performance computing has transformed many scientific disciplines, enabling advanced modeling, simulation, artificial intelligence, and data intensive research. However, despite the growing digitalization of the built environment sector, HPC adaptation remain relatively limited compared to other domains. In this presentation, I will briefly discuss why this gap exists, present the key barrier and enabler identified through our stakeholder engagement activities, and conclude with a user-centered roadmap for supporting more accessible and inclusive HPC adaptation within the built environment. Thank you, and I will begin with some background and motivation for the study. The built environment is becoming increasingly data intensive. Technologies such as BIM, digital twin, IoTs, sensors, and AI generated large volume of complex data. These applications required computational resources beyond conventional desktop computing. HPC offer enormous opportunities for infrastructure simulation, climate resilience modeling, optimization, and real-time decision making. However, despite these opportunities, adaptation remain fragmented and relatively low. This raises an important question. Why is a technology such as clear potential not being widely used in practice? To address this challenge, we adopted a user-centered perspective. Rather than focusing solely on technology performance, we explore the experiences of potential users. Our objective was to understand how awareness, access, governance, workflow, skills, and institutional factor influence adaptation, and to identify practical action that could support wider uptake. A key contribution of this paper is applying a socio-technical lens. Traditional approaches often focus on technical performance. However, technology alone does not guarantee adaptation. Successful implementation required alignment between technology, user, workflow, organization practices, and governance arrangement. Therefore, we view HPC adaptation as a social technical challenge involving people, processes, and institutional as much as computing power. The study used a qualitative user-centered design. We organized a stakeholder workshop involving 20 participants from academia, industry, and technical domain. Participants discussed barrier, governance issues, workflow challenges, and future priorities. Interactive Mentimeter pooling was used to collect anonymous responses and encourage wider participation. The resulting data were analyzed using thematic analysis to identify the recurring patterns and themes. One of the most significant findings was the awareness adaptation gap. Participants clearly recognized the value of HPC. Approximately 70% view HPC as highly relevant for future built environment application. However, fewer than 30% felt confident accessing or using HPC system independently. Many participants describe HPC as something designed for computer scientists rather than built environment professional. Complex access procedure and onboarding processes were repeatedly identified as barriers. Participants also highlighted major workflow integration challenges. Most built environment professionals work with established BIM, GIS, CAD, and simulation environment. Moving these workflows into HPC system often required significant adaptation. Governance concerns were equally important. Industry participants expressed concern about intellectual properties, confidentiality, data ownership, and sharing commercially sensitive information within shared computational environment. These issues can significantly reduce willingness to engage with HPC resources. Skills and organizational factors emerge as another major theme. Many participants reported little or no formal HPC training. They wanted a practical example demonstrating how HPC could support day-to-day built environment activities. Institutional barriers were also significant. The sector is characterized by fragmented supply chain and risk-averse decision-making. Unlike building information modeling, which benefit from the government mandate and strategic implementation programs, HPC currently lacks equivalent policies driver. Based on our findings, we developed a user-centered roadmap for HPC adoption. The roadmap consists of 6 interconnected priorities. First, improving awareness and engagement. Second, simplifying access and onboarding. Third, integrating HPC with existing workflows such as building information modeling and GIS. Fourth, strengthening governance, trust, and data sharing mechanism. Fifth, providing practical training and support. And finally, addressing broader cultural and institutional barrier. The roadmap emphasizes that adaptation requires coordinated action across technical, organizational, and policy dimensions. The ultimate goal is not simply more HPC infrastructure, but more accessible, usable, and trusted HPC infrastructure. To conclude, high-performance computing offers significant opportunities for the built environment sector. However, adaptation remains constrained by a combination of access barriers, workflow integration challenges, governance concerns, skill gaps, and institutional factors. Our findings demonstrate that improving adaptation is not simply about providing more computing power. It requires a user-centered approach that prioritizes accessibility, usability, trust, and alignment with existing practices. The roadmap presented in this paper provides a practical framework for infrastructure providers, policymakers, researchers, and industry stakeholders seeking to broaden participation in high-performance computing-enabled innovation. Thank you very much for your attention, and I look forward to your questions.